You ever see one of those things that just looks like straight up magic, but there's got to be some science behind it? Well, today we're going to tackle a classic puzzle that totally seems to break the laws of physics. It's the incredible egg in a bottle.
Okay, so the setup couldn't be simpler. You've got one hard-boiled egg and one glass bottle. And the goal? Just get the egg inside. Sounds easy, right? But yeah, as you can probably guess, there's a pretty big problem.
Yep, you guessed it. The egg is way too big for the opening of the bottle. I mean, you can push, you can squeeze. It is just not going to happen. It's not going in.
So, that's the big question, isn't it? How on earth do we get this egg inside the bottle without completely smashing it to pieces? Is there some trick? Some way to bend the rules of physics just a little? Well, let's find out.
All right, forget about brute force. We are going to let a little bit of science do all the heavy lifting for us.
Okay, so here's exactly how it works. First up, you need a peeled, hard-boiled egg. Simple enough. Then we're going to light a little strip of paper on fire, drop it right into the bottle, and then, this is the important part, you quickly place the egg right on top to seal the opening.
Okay, so the fire's going inside, the egg is sitting on top creating a seal. Now, all we have to do is watch very, very closely. What do you think is going on inside that bottle right now? Whoa, look at that. There it goes. You can see the eggs start to wiggle. It almost looks like it's stretching. And then, pop. It just drops right into the bottle, perfectly intact. It's like it was just, poof, sucked right in.
Okay, before we get into the how and why of what just happened, just a really quick but super important safety note. Obviously, this experiment involves fire, so please only try this if you have an adult supervising, and just be incredibly careful.
So, what just happened there? Was that magic? I mean, it sure looked like it, didn't it? But nope. This is where some really fascinating science takes over.
All right, time to pull back the curtain and reveal the secret. This whole trick is all about an invisible force that is literally all around us, all the time, air pressure. So get this, right now, the air in whatever room you're in is pushing on you, on everything from every direction. You don't feel it, right? That's because the pressure is all perfectly balanced. But with our little experiment, we just created a massive pressure imbalance. Let's walk through the chain reaction here. First, that burning paper heats up all the air inside the bottle. Hot air expands, right? But then, when the fire goes out, that air cools down, and it cools down fast. And when air cools, it contracts. It takes up less space. And that, right there, is what creates a pocket of lower pressure inside the bottle. So what you have now is basically a pressure battle. On the outside of the bottle, you've got normal, higher air pressure just doing its thing. But inside the bottle, we now have this area of much lower pressure. Suddenly, the force on the outside is way stronger than the force on the inside. And this right here is the absolute key to the whole thing. The egg wasn't sucked in. That's not what happened. The higher air pressure on the outside literally acted like an invisible hand and pushed the egg into that area of low pressure inside the bottle. It all comes down to that rapid cooling of the air inside the bottle. That's the trigger that creates the low pressure you need to make this whole thing work. It's a really simple cause, but man, it has a super dramatic effect. You'll often hear this called a vacuum effect. Now, to be clear, it's not a perfect vacuum like you'd find in outer space, but the idea is pretty much the same. Nature it doesn't like pressure differences. It always tries to balance things out. And in our case, it used the egg as the plug to fill that low pressure space. Okay, so let's just recap the crucial points, shall we? It's not a suck, it's a push. Hot air expands, cooling air contracts, and that creates lower pressure. And really, nature uses these pressure differences to create some seriously powerful forces. And that's what makes this whole thing so much more than just a cool party trick. It's a perfect demonstration of a powerful, invisible force that's working all around us every single day. It's a way to actually see it in action. So that leaves us with one final thought. Now that you know just how powerful a simple pressure difference can be, where else in the world is this invisible force at work? Think about it. From the way airplanes fly to huge weather systems, its effects are absolutely everywhere.